Okay, so everybody should have a piece of graph paper, and we're going to represent all three graphs on the same piece of paper so that we can correlate some information later. So it's important that you follow all of the instructions. Now, we're going to have the y-axes all lining up, and we're going to have the same coordinates along the, or not the same coordinates along the x-axis, sorry. We're going to have the same domain displayed. So it'll be important later so that you can line it up. Anyway, we'll get started. So first thing I'm going to do, because our domain ranges between 0 and 2 pi, first thing I'm going to chuck on is right over here at the end, I'm going to put in 2 pi. Then I'm going to find halfway across, and I'm going to put in pi. Now, that's the easiest way, I believe, to start it off. So now I'm going to look over here at what coordinates I have, and then I'm going to think about the pattern after to help me draw it. So the first one I have is pi on 6. So I'm going to represent pi on 6 as being about here. So there's pi on 6. The next one is 5 pi on 12. So that's slightly less than half. So that's going to be about there. So 5 pi on 12. The next one will be 2 pi on 3, which is slightly more. So 2 pi on 3. Now, if you're wondering how I'm doing this in my head with dividing this line up, I'm thinking about where half of pi is. So half of pi is 0.5 as a decimal. 2/3 as a decimal is 6.66 or 66.66. And so I'm using that to figure out the rest of it. Okay, so over here, I'm now going to orientate my other information. I know that this thing has a minimum of -2 and a maximum of 4. 1, 2, 3, 4. Okay, and I'm going to put my D value in, which is 1, which is going to be right around there. Now, over here, I identified that pi on 6 is where a midpoint occurs. So pi on 6 is where a midpoint occurs. 5 pi on 12 is where a minimum occurs. So 2 pi on 3 is where the next mid occurs. So currently, my sine graph is going to look something like that. Now, in order to fill up the rest of this section, all I have to do is continue the pattern along. So I'm first going to work out what the difference is between these ones and then continue along. If these were working out to be nicer fractions, I might be able to see them straight away. The other thing that I could do is I could see that they're all sections that can be divided up into the 12s, and then I could just skip count along using what I know about the 12 sections. But I find this is the easiest. Okay, so I'm going to find out the difference between these two spaces here. So 2 pi on 3 minus 5 pi on 12. To get them to have the same base, I need to scale this one up by multiplying the top and the bottom by 4 to make it all a fraction over 12. So that would become 2 pi times 4, so 8 pi minus 5 pi will be 3 pi on 12, which can also be scaled to a quarter of pi. Okay, or I could have just split the period in 4, I guess. If I'd done period divided by 4, I'd know what that jump is in between. So now to the next one, 2 pi on 3, I'm going to add pi on 4, which means I'm going to scale this side up by multiplying it by 3, scale this side up by multiplying it by 4. So it's going to be a fraction over 12. So it'll be 8 pi plus 3 pi will make 11 pi. So now my next one is going to be roughly about here, 11 pi on 12. If I keep doing this, so 11 pi on 12 plus pi on 4, scale this side up by multiplying it by 3, so it's all a fraction over 12 of 11 pi plus 3 pi will make 14 pi on 12. It's going to be roughly the same skip, so I can chuck that in now. This can be cancelled down to be 7 pi on 6. So the next one will be over here, 7 pi on 6. Okay, next one, I'm going to add pi on 4 to that one. Scale them by multiplying them both by, think about this. well, I can get them to both be 12. So I'm going to times this side by 2, so that'll be 14 pi on 12. And I'll multiply this side by 3, so plus 3 pi on 12 will be 17 pi on 12. So that one can't be cancelled down. So the next one's about the same distance over here will be 17 pi on 12. Okay, and now we're going to add on another quarter. Unfortunately, these do get a little bit messy. The difference between sketching in grade 11 and sketching 12 is that we introduce the phase shift. Now, for a lot of you, I've already talked about phase shift and I've made you sketch it in year 11 to try and make this process a little bit more familiar to you in year 12. So it really is just about a bit of the old chug and plug. Right, so 7 pi on 12. So now I'm going to add pi on 4, which means I need to scale this side by 3. So 17 pi plus 3 pi will make 20 pi on 12. Both of those can be cancelled down, so it can become, what's the highest common factor here? 4 would be the highest common factor, so 5 pi on 3, which will roughly put it over here. And that should be the last one that we can fit in this domain. So 5 pi on 3. Okay, so now I'm just going to continue the pattern. Min, mid, max, mid, min, mid. So it'll be like that. Okay, so next thing that you need to do is to derive your next function, and then you're going to follow through the steps again. So you'll fill this scaffolding out again for your derived function, and then hopefully by the end we'll end up with, hold on, 3 graphs all on the same. Now obviously this line could be wherever depending on what your domain is, but this part here, the 2 pi has to line up with the 2 pi, 0 has to line up with 0, pi has to line up with pi. Everything else will be fine if you make sure that in all 3 graphs you line up your 2 pi's, your pi's, and your zeros.